Hello students, welcome to Anne's classes. Let's do rational numbers exercise 1A. Page number 9 and we are with question 3, evaluate. So here under question 1 we've been given 4 rational numbers and we have to add them. Now if you look carefully you can see that some of these rational numbers have the same denominators. We have this one and this with denominator 7 and this with denominator 9. So in such cases what we can do is we can rearrange the rational numbers. We can change the order and group them. Group them in such a way that each group will have rational numbers with the same denominator. That is, we're going to have these two rational numbers which have denominator 7 as one group and these two rational numbers with denominator 9 as another group. So let's write that. So let's take this one, that is 3 by 7, and write it first, 3 by 7, and take the next one with the denominator 7, that is minus 11 by 7. So plus minus 11 by 7. So this is one group. Plus, let's take the others. So this will be now minus 4 by 9 and the other one with the same denominator plus 7 by 9. Plus 7 by 9. So this is the second group. So now it becomes easier to work. When the denominators are the same, it's very easy to work because the numerators also remain the same. So this one will now have the denominator 7 and this numerators will be the same. So that is 3 plus minus 11. Similarly, on this side also the denominator is 9. So the numerators remain the same. Minus 4 plus 7. So this will be 3 minus 11 by 7 plus this is minus 4 plus 7. Signs are different. So let's put the sign of the bigger number and subtract. So this is plus and 7 minus 4 is 3. So plus 3. So that is 3 by 9. And this will be 3 minus 11. Signs are different. Put the sign of the bigger number and subtract. 11 minus 3 is 8. 8 by 7 plus 3 by 9. So now we can work on these two rational numbers. Denominators are different. Now we should find the LCM and work out. So let's do that, finding the LCM of 7 and 9. So 7 and 9, let's find the LCM. Use 7, it's a prime number, and bring down 9. Now let's use 3, 1 and 3 threes are 9. Again 1 and 1. So the LCM will be 7 into 3 into 3. 7 threes are 21. 21 into 3 is 63. So the LCM is 63. So here the LCM is 63. Now what we normally do is we look at the first rational number here. Look at the denominator. Now 7 into what is 63? 7 nines are 63. So minus 8 into 9. So the sign is minus, 8 nines are 72. Plus go to the second rational number. Look at the denominator 9. 9 sevens are 63. So 3 into 7. 3 sevens are 21. So write 21 here. Now minus 72 plus 21. Signs are different. Put the sign of the bigger number and subtract. 72 minus 21. 2 minus 1 is 1. 7 minus 2 is 5. That's 51. So minus 51 by 63. Here we can reduce 51 and 63. Both are divisible by 3. So this is 3 ones are 3. What is left is 2, 21. 3 sevens are 21. Here 3 twos are 6, 3 ones are 3. So what do we get here? We get minus 17 by 21. Now this is the final answer, minus 17 by 21. Question 2. Here also we have 4 rational numbers. Look out for rational numbers that have the same denominator and put them into groups. So here we have 2 by 3, and which is the other rational number with the denominator 3? It's plus 1 by 3. So plus 1 by 3. This is the first group. Now look at the second group. The denominator is minus, the denominator is 5. So that's minus 4 by 5 plus the other rational number is 2 by 5. So write down 2 by 5. So this is the second group. Now let's work this out. So here denominators 3, numerators remain the same, 2 plus 1, plus here the denominators 5, numerators remain the same, minus 4 plus 2. Now let's simplify this. 2 plus 1 is 3, 3 by 3, plus here minus 4 plus 2, signs are different, put the sign of the bigger number and subtract. 4 minus 2 is 2, minus 2 by 5. So here we have two rational numbers, 3 by 3 plus minus 2 by 5. Denominators are different. Now we have to find the LCM of the denominators. When you have two prime numbers, you just have to multiply. So 3 5s are 15. So 15 will be your LCM. 15 will be your LCM. Now, like I said earlier in the previous video, I taught you a shorter method of finding the new numerators. You can use that method or the usual method. So according to this shorter method, take the first rational number 3 by 3, multiply it by the LCM, which is 15. Now cancel. 3 5s are 15. Now multiply the numerators. 3 5s are 15. So here we have 15 plus, then the other rational number is minus 2 by 5. Multiply this by the LCM, which is 15. Cancel. 5 3s are 15. Multiply the numerators. Minus 2 into 3 is minus 6. So this becomes minus 6. So this will be 15 minus 6 by 15. 15 minus 6 will be 9. So that is 9 by 15. And 9 by 15 can be reduced to the lowest term. So this both 9 and 15 are divisible by 3. So this is 3 3s are 9, 3 5s are 15. So what do we have here? We have 3 by 5, which is our final answer. Question 3. Now here we have 4 by 7 plus 0 plus minus 8 by 9 plus minus 13 by 7 plus 17 by 9. So anything added to 0 will give you back the same number, isn't it? So this will be 4 by 7 plus 0 is 4 by 7 plus minus 8 by 9 plus minus 13 by 7 plus 17 by 9. So now we can arrange the like terms together, that is those with the same denominator. So 4 by 7 and minus 13 by 7 are like terms. So let's write that 4 by 7 minus 13 by 7. So this forms the first group. Plus, let's take the second group, minus 8 by 9, and the other rational number is plus 17 by 9. This forms the second group. Now let's write down the same denominator as the LCM 7, and the numerators also remain the same, 4 minus 13, plus here also 9. So the numerators remain the same, minus 8 plus 17. Now let's simplify. 4 minus 13. The signs are different, so put the sign of the bigger number and subtract. 13 minus 4 is 9. 9 by 7 plus, now here minus 8 plus 17. So this also is 9 by 9. Now the denominators are different, 7 and 9. We have to find the LCM of the denominators and simplify this. So the LCM of the denominators 7 and 9. So let's do that. 7, 1 and then 9. Now divide this by 3. 1, 3 3s are 9. Again by 3, 1 and 1. So what is the LCM? LCM is 7 into 3 into 3. So 7 3s are 21. 21 into 3 is 63. So the LCM is 63. So we can write this here 63. Now take the first rational number minus 9 by 7. Let's work this out in a different way. Minus 9 by 7 multiply with the LCM. Then cancel. 7 9s are 63. Now multiply the numerators. Minus 9 into 9 minus 81. So we can write that here minus 81 plus. Now take the second denominator 9 by 9. That's the second rational number into the LCM. Now cancel. 9 7s are 63. So here multiply. 9 7s are 63. So here we get plus 63. Let's write it down. Now here we have minus 81 plus 63. Signs are different. Put the sign of the bigger number and subtract. You get 18 when you subtract, and in the denominator we have 63. Now 18 and 63, we can reduce it to the lowest term. We can use 9, we can use a 3. Let's use 9. 9 2s are 18, 9 7s are 63. So what do we have there? Minus 2 by 7. So our final answer here is minus 2 by 7. Question 4. Here, if you look carefully, we have three sets of like terms. We have denominator 8 and 8, denominator 12 and 12, 7 and 7. So there are three sets. That means we're going to get three groups of like terms. So let's begin with the first one. So we have 3 by 8, which is the other one with the denominator 8, It's this. So plus minus 5 by 8. This is your first group. Now let's take the second group with the denominator 12. So that will be minus 5 by 12 plus 3 by 12. Let's write that. So this is plus minus 5 by 12 plus 3 by 12. This is our second group. Now the third group is 3 by 7 and minus 2 by 7, like terms. So that is 3 by 7 plus minus 2 by 7. So now this is the third group. Now let's work this out and see. So here we'll have denominators 8, numerators are the same, 3 plus minus 5 plus here also our denominator is 12 and the numerators remain the same, minus 5 plus 3 plus here again we have 7 and 3 plus minus 2. So now let's simplify this. So this becomes 3 minus 5 by 8. Then here we have minus 5 plus 3, signs are different, so we put the sign of the bigger number and we subtract, so that becomes minus 2. 5 minus 3 is 2, minus 2 by 12 plus 3, remove the bracket, minus 2 by 7. So here 3 minus 5, signs are different, put the sign of the bigger number and subtract. 5 minus 3 is 2, minus 2 by 8, minus 2 by 12, and here what do we have? 3 minus 2 is 1, 1 by 7. So now as you can see, the denominators are all different. So we have to find the LCM of these denominators. So let's do that. 8, 12 and 7. Let's begin with 2. 2 4s are 8, 2 6s are 12. We bring down 7. Continue with 2 again. 2 2s are 4, 2 3s are 6. Bring down 7. Again we're going to use 2, 1. Bring down 3 and 7. Use 3 this time. So 1, 1. Now bring down 7. Now we have to use 7. So it is 1, 1 and 1. So what is our LCM? LCM is 2 into 2 into 2 into 3 into 7. So 2 2s are 4, 4 2s are 8, 8 into 21. And how much is 8 into 21? That is 168. So that is our LCM, 168. So let's write that down. Now we have to get our numerators. So let's take the first rational number minus 2 by 8 and multiply it with the LCM. So minus 2 by 8 into the LCM, which is 168. So we have to cancel 8 and this LCM. So let's try that. So cancel, this is 8 1s are 8. Here 8 2s are 16, 8 1s are 8. So when you multiply 21 into minus 2, we get minus 42. So let's write that here, minus 42 plus, now here 12, this is a denominator. Let's take that rational number, minus 2 by 12 and multiply this with the LCM, which is 168. Now we can cancel 12 and 168. Now let's use 4 and see. We'll try with 4. Okay, 4 3s are 12, 4 4s are 16, 4 2s are 8. Now again let's try with 3. 3 1s are 3. Now here 3 1s are 3. There's 1 left now. So that's 12. 3 4s are 12. So we have 14. Now multiply the numerators. 2 into 14. So the sign is minus. 14 2s are 28. So we can write that there, minus 28. And the last one is 1 by 7. So let's take 1 by 7 and multiply it with the LCM, 168. So here we have to cancel 7 and 168. So let's try that slowly. 7 and let's take only 16. 7 2s are 14, isn't it? 4 2s are 14. 15, 16 is 2 left. So now we write the 2 here. Now the number is 28 and 7 4s are 28. That means 1 into 24 is 24. So let's write that here. This is 24. Now let's remove the brackets. So this is minus 42 minus 28 plus 24 by 168. So now we need to work this out. So here we have numbers with the same sign, 2 minus signs, 1 plus sign. So let's work on these. When signs are the same, we put the same sign and we add. So this becomes minus, when you add 42 plus 28, you get 70 plus 24 by 168. Now minus 70 plus 24. Signs are different. Put the sign of the bigger number and subtract 70 minus 24. You get 46. So this is 46 by 168. We can now reduce this to the lowest term by using 2. So let's use 2. 2 2s are 4, 2 3s are 6. Here 2 8s are 16 and 2 4s are 8. So what do we have? Minus 23 by 84. So that is our final answer, minus 23 by 84. Final answer is this. Question 4. For each pair of rational numbers, that is, this is one pair, verify the commutative property of addition of rational numbers. So this is one very important property called the commutative property of addition of rational numbers. What does that mean? Now here we have a pair of rational numbers, and here according to this we should write minus 8 by 7 plus 5 by 14. According to commutative property, even if you change the order, the answer will be the same. That is, if you add up this first and this second, or this first and this second, the answer will be the same, and that is called the commutative property. So commutative property of addition is, if A by B and C by D are any two rational numbers, then when you add them up in one particular order and you change the order and you add them up, they will still be equal. So we have to prove that here. So let's do that. So first let's put it in the same order and add it up. So that means we're going to add minus 8 by 7 plus 5 by 14. Now as you can see, denominators are different. So let's find the LCM of 7 and 14 using 7 itself. Now 7 ones are 7, 7 twos are 14. Now use 2, 1 and 1. So what is your LCM? 7 into 2, which is 14. Now let's use that. So now let's use this LCM 14 and find our new numerators here. So this will be 14, and we can use any method to find the new numerators. 7 2s are 14. So minus 8 into 2 is minus 16. Plus, now when you go to the other one, 14 into 1 is 14. So 5 into 1 is 5. So we write that 5 here. Now minus 16 plus 5 is minus 11. Minus 11 by 14. So we got minus 11 by 14 when we put minus 8 by 7 first and 5 by 14 second. Now we have to verify this property, commutative property, that is, we have to change the order and add and see if our answer is still the same. So now let's change the order. This time we are going to write 5 by 14 first. So 5 by 14 plus minus 8 by 7. So here the LCM will be 14. We've just found out the LCM. So let's use the same thing. 14. Now take the first rational number. Denominator is 14. 14 into 1. So 5 into 1 is 5 plus. Now the next one. Denominator is 7. 7 twos are 14. So minus 8 into 2 is minus 16. So this will be 5 minus 16 by 4. When signs are different, we put the sign of the bigger number minus by 14. Okay. So we put the sign of the bigger number and we subtract 16 minus 5 is 11. 11 and the denominator is 14. So when we first added, we got the answer as minus 11 by 14. When we changed the order and we added, also we got minus 11 by 14. So here what have we proved? We have proved that whether you add it up this way or change the order, it's the same. So we need to write that. So how do we write that? We say minus 8 by 7 plus 5 by 14 is equal to 5 by 14 plus minus 8 by 7. Okay, that is, we have proved that the commutative property is satisfied in this question. Question 2. Now we are going to verify the commutative property for the addition of these two rational numbers. So first we arrange it in this order and we add, and then we change the order and then we add. And let's see if the answers are the same in both the cases. So let's begin with addition of these two rational numbers in this same order. So that will be 5 by 9 plus 5 by minus 12. So as we know, 5 by 9 here remains the same, but when you have a minus sign in the denominator, you transfer it to the numerator. So that becomes minus 5 by 12. So now we're going to find the LCM of 9 and 12. So let's find the LCM. Let's use 3. 3 threes are 9, 3 fours are 12. Continue with 3. 3 ones are 3. Bring down the 4. Then use 2. 1 and 2 twos are 4. Continue 2, 1 and 1. So the LCM will be 3 into 3 into 2 into 2. Multiply 3 threes are 9, 9 twos are 18, 18 twos are 36. So the LCM is 36 and we're going to use that LCM here. So this is 36. Then we can use any method to find the numerators. Now here 9 fours are 36. So 5 fours are 20 plus, now here we have minus 5 by 12. Look at the denominator. Denominator is 12. 12 threes are 36. So multiply this also by 3. Minus 5 into 3 is minus 15. So this is minus 15. So this becomes 20 minus 15 by 36. So 20 minus 15 is 5. 5 by 36. So what did we do? We added this in the same order as it's given in the question and we got 5 by 36. Now let's reverse the order. So we're going to say 5 by minus 12 plus 5 by 9. So here what have we done? We have reversed the order. Here first 5 by 9 comes. Now here we're writing it second. And now let's find the sum after adding this. So this becomes minus 5 by 12 because the denominator has to be positive plus 5 by 9. Now we have to find the LCM of 12 and 9 which we have already found and it is 36. Now look at the first denominator here, it's 12. So 12 threes are 36. So multiply minus 5 by 3. Minus 5 into 3 is minus 15 plus the next rational number denominator is 9. 9 fours are 36. So 5 into 4. 5 fours are 20. So here what do we have? Minus 15 plus 20. Signs are different. Put the sign of the bigger number, that is plus, and subtract 20 minus 15 is 5. 5 by 36. So here the answer is 5 by 36. So can you see? We've got the same answer when we had 5 by 9 first and added, we got 5 by 36. When we changed the order also, we got 5 by 36. So we have verified this. So we can say 5 by 9 plus 5 by minus 12 is the same as 5 by minus 12 plus 5 by 9. That's verifying the commutative property. Question 3. So here first let's add this in the same order as it's given to us. Minus 4 by 5 plus minus 13 by minus 15. So minus 4 by 5, let's write it as it is, minus 4 by 5 plus, now here minus 13 by minus 15, since we have a minus sign on top and down, we can cancel it. So now this is simply 13 by 15. Now we have to find the LCM of 5 and 15. So we can do this with the help of 5. 5 ones are 5, 5 threes are 15, and then go to 3, 1 and 1. So the LCM is 5 into 3, which is 15. So let's use that. So here the denominator is 15. So let's use the other method now, okay, to find the LCM, to find the new numerators. So take the first rational number, multiply it by 15. So let's take the first one. So minus 4 by 5 into 15. Now I'm using both the methods. Whichever is easy for you, you can use that. So here let's cancel this. 5 threes are 15. So here we have minus 4 into 3 is minus 12. Let's write it there. Minus 12 plus, next one is 13 by 15. So let's take that rational number 13 by 15. Multiply it by the LCM. You can cancel 15 and 15 and what is left is 13. So let's write that. So that is 13. So here look at the two numerators, minus 12 plus 13. Signs are different. So we have to put the sign of the bigger number and subtract. 13 minus 12 is 1. So here we have 1 by 15. So this is the answer that we get when we add it up as it's given in the question. Now let's reverse the order. Let's write minus 13 by minus 15 first plus minus 4 by 5 second. So here again, remember this gets cancelled. So what do we have there? We have 13 by 15 plus minus 4 by 5. Now we have to find the LCM of the denominators 15 and 5. We've already found the LCM, it is 15. So let's write 15 here. Now take the first rational number 13 by 15 and multiply it by this. So we've done that. We've taken the first rational number, multiplied it by the LCM, and we get 13. So let's write 13 there, plus take the second rational number, that is minus 4 by 5, and multiply it with the LCM 15. This gets cancelled and what you have is minus 12. So let's write that 13 plus minus 12. Now this becomes 13 minus 12 by 15. 13 minus 12 is 1, 1 by 15. So when we add it here, we got 1 by 15. It's the same as the answer that we got here. So we can conclude that when you add minus 4 by 5 plus minus 13 by minus 15, it's equal to the same thing even if the order is reversed, plus minus 4 by 5. Thus we have verified the commutative property. Question 4. So here let's add up this in the same order given. So this is 2 by minus 5 plus 11 by minus 15. Let's transfer the minus sign to the numerator. So minus 2 by 5 plus minus 11 by 15. So let's find the LCM of the denominators 5 and 15. We found out in the previous question. It is 15. Now take the first rational number minus 2 by 5, multiply it by the LCM 15. Cancel 5 and 15, that is 3. So minus 2 into 3 is minus 6. So that is our first numerator. We can write it here. Plus, now here we can use this here itself. 15 ones are 15. So minus 11 into 1 is minus 11. Now let's remove the brackets. It becomes minus 6 minus 11 by 15. So when signs are same, put the same sign and add. 11 plus 6 is 17. Minus 17 by 15. So this is the answer when we add it as it's given in the question. Now let's change the order and write. So let's write 11 by minus 15 first, and now let's write 2 by minus 5. So we have reversed the order. So this is the order given to us. We have changed the order. Now let's add and see. So change the minus sign from the denominator, transfer it to the numerator. So it becomes minus 11 by 15. Similarly, here it becomes minus 2 by 5. So minus 11 by 15 and plus minus 2 by 5. The LCM is 15. And here, take the first rational number, denominator is 15. 15 ones are 15. So minus 11 into 1 is minus 11 plus, now let's do the next one. Now here we have minus 2 by 5 into 15, we get minus 6. So let's write minus 6. So this is minus 11 minus 6 by 15. So what do we get? Minus, the sign is the same, put the same sign and add. 11 plus 6 is 17 by 15. So here after adding we got minus 17 by 16, which you can see is the same as this. That means we have verified the commutative property. So how do we write that? We say 2 by minus 5 plus 11 by minus 15 is the same as 11 by minus 15 plus 2 by minus 5. Even if you change the order, the answer is going to be the same for addition. So this is known as the commutative property for addition. Question 5. Here we have 3 and 2 minus 2 by 7. So let's write this as 3 by 1 plus minus 2 by 7. Now here the LCM will be 7 only. So let's look at the first one. 1 into 7 is 7. So 3 into 7. 3 into 7 is 21 plus, now here 7 is the same. So 7 ones are 7. Minus 2 into 1 is minus 2. So this will be 21 minus 2 by 7. 21 minus 2 is 19. 19 by 7. So what is the answer that we've got here? We've got 19 by 7. Now let's change the order. So let's put minus 2 by 7 first and add 3. So this will become minus 2 by 7 itself plus 3 by 1. Now we have to find the LCM. The LCM is 7. Now here it is 7 into 1 is 7. So minus 2 into 1 is minus 2 plus, next we have 1, 1 into 7. So 3 into 7 is 21. So now what do we have here? We have minus 2 plus 21. Signs are different. So we have to put the sign of the bigger number, which is plus, and subtract. 21 minus 2 is 19. So we have 19 by 7. So we've got our answer here also. So as you can see, the answers are the same. That means if you add it in this order, you get an answer. When you add it in the reverse order, you get the same answer. So let's write it like this. 3 plus minus 2 by 7 is equal to minus 2 by 7 plus 3. So what have we verified? We have verified the commutative property for addition. Question 6. So here we have minus 2 and let's add that up. Minus 2 by 1 plus 3 by minus 5. So this is minus 2 by 1. Now here we're going to transfer the minus sign to the numerator. So minus 3 by 5. Look for the LCM. The LCM is 5. Look at the first rational number. Denominator is 1. So 1 into 5. So multiply this also into 5. That becomes minus 10 plus. Now here we have 5 into 1. So minus 3 into 1 is minus 3. Now let's remove the brackets. Minus 10 minus 3 by 5. Minus 10 minus 3 is, put the same sign and you add. 10 plus 3 is 13. Minus 13 by 5. This is our rational number, which is our final answer here when we add it in this way. Now let's change the order and add. So 3 by minus 5 plus minus 2. We are changing the order. So let's transfer the minus sign to the numerators. This becomes minus 3 by 5 plus minus 2 by 1. Now the LCM is 5 itself. Look at the first rational number. Denominator is 5. So 5 ones are 5. Minus 3 into 1 is minus 3. Plus the second rational number. Denominator is 1. 1 into 5. So minus 2 into 5. So here it becomes minus 10. Let's remove the brackets. Minus 3 minus 10 by 5. Signs are the same here, isn't it? We have minus 3 and minus 10. So let's put the same sign and add. 3 plus 10 is 13 and the denominator is 5. So what is our answer? Minus 13 by 5. So the answers are the same. That means we have verified the commutative property here also. So minus 2 plus 3 by minus 5, this is given to us in the question, is the same even if you change the order. So minus 3 by minus 5 we have written first, plus minus 2 we have written second. The answers are the same. So we have verified the commutative property for addition. We'll stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.